Hi everyone, so for this video I'm going to work through a selection of problems on this worksheet. It is rational exponents and radicals. So I'm going to kind of go section by section and pick one or two problems just to take a look at together. So here on this first section I want to convert from rational exponent form, which we have here, and we want to convert that over to radical form. When we do that, remember that the denominator of our rational exponent becomes the index, or the root we are going to take. In this case, this 3 becomes the fifth root. And then the exponent goes inside the radical. The numerator of the rational exponent becomes the exponent inside the radical. If we'd like, we can simplify this by taking out 1n cubed. So our final simplified form would be n times the cubed root of n squared. Let's scroll down and look at number 5. Here we want to rewrite this. We know a few things using exponent rules, but the most important thing is going to be getting rid of our radicals. So a square root is the same as the this exact look here, right? The square root of x is the same as 2 as an index and a 1 as an exponent. So I can rewrite this as x to the 1/2 to the third power. And then I can simplify this even further by taking my exponents and multiplying them together. 3 times 1/2 is 3 halves. I'm going to jump down to number 9 now. Here we have 125 to the third, to the 1/3 power. So some of us may like converting this to a radical first. The 3 becomes my index, the 1 becomes an exponent we don't need to write. And if I want to go ahead and simplify that, I need to figure out the cubed root of 125. What number times itself 3 times equals 125? And that is 5. Let's try one that's also got a negative in it. So here on number 10, I have 25 to the negative 1/2. Now remember, negative exponents do not create negative numbers, they create fractions. So I could write this as 1 over 25 to the 1/2, which is the same as 1 over the square root of 25, which once I simplify that square root, I will get 1 over 5. I'm going to pick a few from the remaining problems here that are particularly interesting. Let's start with number 14. So I know that I'm multiplying a few numbers together here, and maybe this will make a little bit more sense from an organization standpoint if I kind of reorder things. If I had 3 times 2 times a to the 5/3 times a to the 1/3 times a, let me give myself a little bit more room here, to the 5/3. Well, right away I can multiply 3 times 2. I know that's going to be 6. And then I can simplify all my a's here. Well, I have 5/3, 5/3, and 1/3. That's a total of 11/3. Now, if I wanted to simplify this in radical form, this would be 6 times a to the third times the cube root of a squared. I can think about 11/3 as 3 2/3. So when I simplify this, I have 3 entire a's and then 2 partial a's inside the radical. So the preferred form here is in radical form. So fully simplified, I should get 6a cubed times the cubed root of a squared. Just as a note, if you know you're simplified or not, your index should always be larger than your exponent. If it's not, there's more work you can do. Let's jump down to number 18. So there's a couple parts we have to deal with. We have to deal with the numerator and the denominator. The numerator looks pretty easy. Let's deal with that first. This 0 only applies to the x. So this is really 2 times x to the 0. Well, x to the 0 is 1. So our numerator is really just 2. Our denominator, because we have these parentheses here, this exponent 3/2 needs to go to every member inside the parentheses. So 4 to the 3/2 times x to the, well, we could write this as 12/2. Hopefully you see how we can simplify this. The denominator, 4 to the 3/2. That's really the square root of 4 cubed. The square root of 4 is 2. 2 cubed is 8. So this is going to be 2 over 8. And x to the 12/2. Well, I can simplify 12/2 to 6. And my final step here, I can simplify 2 over 8. I can write this as 1 divided by 4 times x to the 6th. I know I'm done. All my exponents are integers. Nothing's negative. And I can't simplify any of my fractions any further. Let's move on to number 21, and then we'll look at 24 to finish. For number 21, I have negative exponents in a few different places. My recommendation is to get rid of as many of your negative exponents as you can from the start. So I can rewrite this. I know that this exponent can move this term to the denominator. I can write this as 1 over n to the positive 5th, all to the negative 2/3. I also can use this negative exponent on the outside. Negative exponents create reciprocals. So if I have a fraction, I can write this as n to the 5th over 1. I don't necessarily need that. But now I have a positive exponent of 2/3. So now I can distribute that 2/3 to the 5, and I'll get n to the 10/3 over 1, which I don't need to write. And once we simplify this down, this will be n to the 3rd times the cubed root of n. And finally, let's look at number 24. We have a single variable here. We have x in the numerator and denominator. So we're going to be really dealing with all of our exponent rules. Let's simplify the numerator first and see what happens. Well, let's get a new color in here. We'll get x to the 1/4 in the numerator, because when I multiply 1/2 times 1/2, I get 1/4. And then in the denominator, I'm going to try to combine those x's. I have 3/2 and -2. Well, what I'm going to do as this first step is I'm going to rewrite this with a common denominator. I know that I'm multiplying exponents here, so I'm multiplying common bases, so I need to add exponents. So this is going to be 3/2, and this will be x to the -4/2. Alright, so now when I simplify my denominator, I'm not really liking this green, I'm going to get x to the 1/4 in the numerator over x to the -1/2 in the denominator, because 3/2 plus -4/2 is -1/2. Half. Now I don't like my negative exponent, so let's move that up to the numerator. So this is the same as x to the 1/4 times x to the 1/2. And when I add those together, I should get x to the 3/4. And in radical form, that is the 4th root of x cubed. And I'm done.